Okay, so we're going to be solving systems of inequalities. So yesterday we were solving with one inequality. Today we're going to have two or more inequalities and we're going to have to solve. So your solution will be where they're all shaded. Okay, so on number one, we have 2x minus y is greater than or equal to 4 and x minus 2y is less than 10. So those are systems of equation or systems of inequalities. We're going to graph each one. Notice that they're in standard form, so we're going to use the intercepts like we did on notes 2-6. Okay, so I'm going to find the x-intercept of 2x minus y is greater than or equal to 4. Remember, when you have an x-intercept, your y is 0, so it's like it's not there. So divide by 2, and so your x-intercept would give you 2. And then to find your y-intercept, we know when we have a y-intercept, our x value is 0, so we're going to mark that out. And then we'll solve for y. Notice it's negative y, so that means positive y would equal negative 4. So those will be my two intercepts of my first line. So I have x is 2 and negative 4 on the y. And then notice we talked about when it's equal to, it's a solid line. So we will connect the 2 points. Make sure you finish the line all the way through the graph. And then we're going to figure out where we need to shade. Okay, so we talked about that yesterday. We're going to plug in a test point. So I'm going to plug in just 0, 0. That's the easiest one to plug in. So when I plug that in for x and y, I get 0 is greater than or equal to 4, which is a false statement. That means that our 0, 0 point will not be where we need to shade, because it's false. Okay, so I would need to shade below. Now, you could go ahead and shade, but I'm going to draw some arrows because I only want to shade my solution, which will be where all of them are shaded. Okay? All right, so then I'm going to look at my next inequality. So that second one is x minus 2y is less than 10. And I'm going to find the x-intercept. So I know y is 0. So the x-intercept would be 10. And then the y-intercept, x minus 2y is less than 10. We know x is 0. So see, notice we have negative 2y will be equal to 10. So y would be equal to negative 5. So that would be your y-intercept. So x is 10. Y is negative 5. Notice that it's not equal to on that inequality. That means we'll have a dotted line. It will include the points on the line. So we'll make that a dotted line through those 2 points. Make sure you extend it throughout the whole graph. And then we're going to find where they're both shaded. So on that green one, we're going to plug in a test point of 0, 0. So we end up getting 0 is less than 10, which is true. So we need to shade where 0, 0 is at. So that would be above the line here. And so this area here would be our solution. That's where they're both shaded at. Okay, so you could plug in anything in that shaded area and it'd be true into both inequalities. You could also plug in something that's on this pink line here, but not something that's on the green one because it's dotted. Okay, so when it's dotted, it's not included. Solid, it is included. Okay, so let's take a look at number 2. Notice that we have 3 inequalities on this one. And notice that the first one, we don't have a y. When there is no y, that means there's no slope. So you won't have a y-intercept, but you will have an x-intercept at 6. And it's less than, it's not equal to, so that would be a dotted line. And it's a vertical because there's no slope. Okay, so we need to see where we need to shade. It's a vertical line. So I'm just going to plug in a 0. So 0 is less than 6. That is true, which means we would need to shade to the left because that's where our 0, 0 is with this line here. So again, if you want to shade everything, that's fine. Just make sure you darken your solution, which means where everything is shaded. Okay, so then we're going to look at our second inequality. I'm going to find the x-intercept. And so we know y is 0, so x would equal 4. And then y-intercept, cover up x, y would equal 4. And notice it's not equal to, so it's dotted. Extend that line. And then we're plugging in 0, 0 for x and y, so that we would get 0 for a test point. So we get 0 is greater than 4, which is a false statement. That means 0, 0 is not in your solution, so we would have to shade the other direction. So we would have to shade above that blue line. Now notice we have one more inequality, so we're going to have to graph that one also, and then we'll figure out where all three of them are shaded. I'm going to find the x-intercept, so I'm going to cover up y because y is 0 when we have an x-intercept. So our x would equal 8. And then we have x plus 2y is less than 8. I'm going to find the y-intercept. So cover up x. So y would equal 4. So we divide by 2. And it's not equal to on that one also, so we have a dotted line again. Extend your line there. And then we'll plug in our test point of 0, 0. That's the easiest one to plug in. So we end up with 0 on the left side is less than 8, which is true. So we would have to shade below this green line. So this section here would be our triple shaded area where they're all three shaded. So we could plug anything in to any part of that shaded part, and it should be true for all three of the inequalities. So that's what you're trying to find, are all the points that would make all 3 or 2, depending on how many you have, true in your system of inequalities. Okay, we'll look at the last one. So I'm going to find the x-intercept of the first one. So cover up your y. So x would equal -9. And then finding the y-intercept. Cover up your x. So y would equal +3. -9 on the x, +3 on the y. And it's not equal to, so it's dotted. Make sure you extend that line throughout the whole graph there. And when you plug in a test point, I'm going to plug in 0, 0. So 0, that's what you'd end up with on the left side, is greater than -9. That is a true statement. 0, 0 is below the line, and it's true, so that means we would have to shade below. So I'm going to draw those arrows there. Okay, looking at this second one. Finding the x-intercept, cover up y, divide by 4, so x would be 1. And then to find your y-intercept, y would equal -4. And it's not equal to, so dotted. And then plugging in 0, 0 for our test point to figure out where we need to shade. we would get 0 is greater than 4. That is false. So we know 0, 0 is not in our solution. So we would have to shade below the line, which is to the right there. All right, and then the last one, we have x plus 2y is greater than negative 2. We're going to find the x-intercept. Cover up y, so your x-intercept would be negative 2. And then to find your y-intercept, we cover up x, because x is 0 when we have a y-intercept. And then when you divide, you get y equals a negative 1. And it's not equal to in your inequality, so it's dotted. Plugging in a test point of 0, 0, we end up with 0 is greater than negative 2, which is true. So we would have to shade above this blue line. So the green one is shaded below. The pink one is shaded below here, and then the blue one is shaded above. So this section here would be where they're all 3 shaded. So you can plug in any point into all 3 of them, and it should be true in that triple shaded area there.